begin.
Okay, today we're going to do the magnetic field measurement lab. You can see for our setup, we have a magnetic probe measurement. This will measure in two axes, both the axial and the perpendicular field. This probe uses the Hall effect that we had discussed earlier. We also have here a 200 turn coil, so we can get a nice strong magnetic field from this. The coil is driven by the 850 interface, so we'll turn on, supply some voltage to it, have current flowing in. You see current comes in through this side, out through the other side. The current is going around the field in this around this way. It's measuring this direction. We're going to measure a nice, strong, positive axial magnetic field. First thing we're going to do today is just do a free measurement. I'm going to have the probe on. I'm going to turn on the coil. We'll have current flowing through. We'll see how much current we have. We will measure a magnetic field at various places around the coil. So if I turn on the interface, we'll see we have current flow. You'll notice as I come in, as I measure along the axis, we'll do this more carefully later on. As I get closer to the center of the coil, the magnetic field is getting stronger. There's an axial magnetic field on the top here. The perpendicular field down below is staying fairly constant. It's down an order of magnitude below the axial field, which as it should be. Now let's just go off axis, just for grins. I'm going to come closer to the coil. Notice the magnetic field is getting stronger. If I get close to the coil, the magnetic field is getting stronger and stronger and stronger. That is consistent with what we've seen from Ampere's law. As you're closer to the conductor, the magnetic field is stronger. But with a coil like this, the mathematics gets very complicated. We're not going to get into that level of detail. That's calculus beyond what I can do. I'm not sure that's what you could do at this point. All right, so that is the free probe measurement. You can stop. Okay, good. All right, so now in this part, we're going to carefully measure the magnetic field along the axis through the single coil. Now this part of the lab, in the before times, if you were here, you'd be spending a lot of time setting up this measurement. An accurate measurement is critically important here. So this time, your grade is entirely in my hands. It's completely out of your control. If you aspire to upper management someday, you will see what it's like to depend on things that are totally out of your control. Right, so for here, the key thing, the most important thing is to have make sure that this probe goes right through the center axis along here. So we'd spend a lot of time getting this carefully set up, measure the width of the coil and make sure that the probe is set exactly in the center here, set it up both horizontally and vertically. I can set my ruler right through these little holes on the side here, make sure that the white probe, the actual axial probe, is sitting right in the center of this ruler. So I've got my vertical about right. It's close here. Side to side, we can look at it. We want to make sure that it's set. I'm looking from above here. I can see the center axis of this base. Make sure that the probe is properly set. Finally, we need to check the X direction as well. I want to make sure that the zero position of this probe is right in the center of this coil. So the coil is 2 centimeters wide. I set a ruler across here, setting a reference point. I check with my ruler above and make sure that my probe is 1 centimeter back. It's setting dead center, right in the middle of this coil. Now, as I move it back and forth, we have a rotary motion sensor here. This will determine the position. So this rotary motion sensor goes into this geared rack and pinion arrangement. As we move it back and forth, the sensor will determine how far we have moved in the X direction. So it'll determine what is the exact position of the probe. So now we come over to the software, we go into our setup. I zero the rotary motion sensor. I want to make sure that we are in fact at our zero position. Good. I'm now going to start collecting data. We have our signal generator. It's going to put 10 volts into it this time. We have a lot of current flowing. So I have to first back up. We're going to back all the way up. I'm going to turn on. We're now recording data, and I push forward. We're going to send the sensor through the coil out to the other side. And we have a beautiful set of data. This has come to you in the Google Sheets document. You'll see this data. You're going to do a curve fit to it using the formula for the field along the axis of a single coil.
Right.
All right. All right. So the next part of the experiment, we're going to look at what's called a Helmholtz coil. This is two coils now with current flowing in the same direction. We're creating the same magnetic field. It's going to reinforce and add. You can see in the theory part of the lab, as long as the spacing between the coils is on the order of the radius of the coil, we should have a constant magnetic field in the region between the two coils. So we're going to investigate that now. We're going to see what the quality of the field is, and also what is the strength of the magnetic field, how does it compare to theory. So you can see we've set up the two coils. We're using the same careful arrangement, making sure that the probe is perfectly centered, going right along the axis. I've zeroed the position now when the probe is sitting exactly right in between the two coils. So I've had it zeroed. I'm setting up. I'm going to back up. I'm going to pull this out. Then we're going to come over, start the setup, and we're going to begin recording. Here we go. We're recording. I'm going to send the probe through both coils now. I recorded the data. You're going to do the theoretical fit to the data. So again, as before, the data is in the Google Sheets document. To check this, you're going to do some curve fitting, see how it fits against the theory. Okay, we're going to measure the magnetic field inside a solenoid. As I discussed the other day, a solenoid is a long helix, long spiral coil. As opposed to the Helmholtz coil, where it's over a very short distance, here this helix covers a very wide range. In the middle here, we should have a very good uniform magnetic field. It will not vary either in the position, coming back and forth here, nor will it vary as we go side to side. So the very first thing I want to do is just explore that. We have the magnetic probe all the way inside the coil. I'm going to turn on the current. We have just about 7/10 of an amp. I'm going to move the coil around very slightly. Move it in and out a little bit, move it side to side. And I will send the data to you. I'll send a copy of this plot. You'll see there's very little variation in the field as we move the probe around here. It's a nice uniform magnetic field, very forgiving. It's a good thing for you if you're doing this experiment live. Extremely forgiving for the exact positioning of the probe. Okay, good. All right, so in this part of the experiment, we're going to look at the magnetic field as a function of the current flowing through the solenoid. Now, you saw this the other day when we were doing Ampere's law. You've seen how we should see the magnetic field varying directly with the current flow through the coil. So let's investigate that. Again, have the setup here. I'm going to use with the Pasco capstone setup, we're going to sweep the voltage. That will change the current flowing through this. In your data, you will see a plot of the current versus the voltage. So we have the setup done exactly as we did before. I'm going to come over here. I'm going to start record. You'll see as the voltage is increasing, the current is increasing, the magnetic field comes up. There's a full set of data. You have that in your Google Sheets document. You will analyze the data. See what is the dependence of the magnetic field on the current. From that, we can determine what is the density of the coils. How many coils per centimeter do we have in the solenoid? All right, so in this part of the experiment, we're going to look at how the magnetic field changes as we go from the center of the solenoid out through the edge. So I have zeroed the rotary motion sensor. We're going to start it at the zero position there in the center of the coil. As we pull the probe out, you will observe the magnetic field changing. I will send you, in your write-up, you'll see a snapshot of how this data appears. So we'll go ahead and start. I'm going to record the data. We will pull the sensor out from the, back we go. Okay. And you will observe the magnetic field drops off, the axial field drops off. There will be a slight shift in the perpendicular field. It's gone from basically zero to a large chunk as we come out.